Thank you for taking the time to look at motion worksheet number 1 with me. By viewing this video, you should get a lot of help with a few questions that could trip you up. The first question could be confusing because of the amount of vocabulary that it uses. For example, displacement. If you don't know where it is, where could you look to find the definition of displacement? I would turn to your notes, online, or if you're with a textbook, you could look it up. And even the word defines could be confusing because you're used to answering that with words and not with math. Well, let's go in that direction. Displacement is how far and in what direction you go compared to where you started. It's how far you end up from where you started. I'm going to write that in just a little bit of a different way. Displacement is your final position minus your initial position. How far you go from where you started. And as you move further on in physics, you become a little bit more detailed about direction. But we're just talking about motion in one direction at this point. So I'll use the x-axis when I write it mathematically. Your displacement is your final position minus your initial position. And all the direction is handled by positives and negatives. A positive displacement will be moving in whichever way you say is the positive direction, and a negative displacement, well, would mean that you've moved in the negative direction on your arrow. An arrow which is conveniently just right here. Number 2 could be tricky because perhaps you are not comfortable imagining this situation, or you don't feel free to do this estimation, which I'm allowing you to do. Imagine a NASCAR race car completes 200 laps to finish a race. Assume it stops at the same spot it started. Okay, for the following 2 questions, which I won't read, the real key comes down to understanding the definition of distance and displacement. I just went over the definition of displacement here. And I'll give you a tip. One of these 2 would be answered as 0 meters because it is 0 meters away from where it started. Like its initial position and final position are the same. For the other one, there's another word here, either distance or displacement, that means the total distance it travels, like step by step, or spin of the wheel by spin of the wheel. And it does go around a track 200 laps. It's up to you to make a guess about how long the track is. There's no right answer. It's an estimation. After looking at other students do this work, I found that not many people got stuck on this imagination exercise regarding frames of reference. So I'll move on to question number 4. Just like question number 1, there are a few different ways to answer this. Because it's more useful, instead of writing down all the words, I'll write down the math equation and then say the words. So one way you can define average velocity is velocity average equals the final velocity plus the initial velocity over 2. And this looks a lot like other averages that you've done. You know, adding up a bunch of things and then dividing by the number of things you added. In class, you probably haven't seen that one yet. There's another way to define it. In fact, many people are comfortable with seeing it inside this triangle. Well, this triangle isn't exactly a definition yet, but it's a really great math helper. Okay? And what does it mean? It means average velocity, which I cover up, equals displacement divided by time. Velocity average equals displacement divided by time. So these two have the same information, both a algebra way to write it and like a math helper way to write it. This one uses totally different information. When someone asks you for the average velocity or one of these pieces inside, you'll have to decide whether this is a better fit for the information you have or this is a better fit for the information you have. Okay, I'll answer question number 5, and then I'll leave question number 6 completely up to you. What is the average velocity of a school bus that takes 0.530 hours to travel a displacement of 10.1 kilometers? I'll make a few notes here just to see what we have. Like, I'm making sense of this. We're talking about what is the average velocity. And then it uses this word displacement, which I've been writing in symbols already quite a bit. And you can see it appears here, and it appears here. Now, before we get too deep into this one, let's look at the steps that you need to do to solve a physics problem. Solving a physics problem is a little bit different than solving a math problem because you're trying to make sense of the real world and there's a lot of stuff to organize. So it probably makes sense to you that we start off by finding the important equation. Without knowing which equation you're going to use, you will be completely lost. Also, it's the most important thing for you to show me that you understand, because the important equation is a big physics idea written in a simple way. For example, acceleration is something about velocity and time, or velocity is something about distance and time. Those are big ideas. Sometimes the equation that you look at on like your notes is written in a different way. So perhaps you need to cover up a different part of the triangle, or you have to use algebra to rearrange it. You want to rearrange it so that it's solved for the thing you're being asked for. Or in other words, you want to write it so that it answers the question. Okay, we have 2 steps, and these go hand in hand. Let's put those into action on problem number 5. Well, in the process of finding your equation, you often need to identify what you know and what you want to figure out. So what is the average velocity? I'll make a note that I want to find that. The average velocity will have to be in my equation. Here's a time information. So I have a time information, and I also have displacement. And I could either highlight or underline the words, anything that tells me what I need. Now it's time to choose an equation. I'll look at this one first. Notice that in my problem, final velocity and initial velocity are never mentioned in the question. They never talk about how fast the school bus is going, period. Also, this equation doesn't have time in it, and it doesn't have distance or displacement. This one is a bad choice. Let's look at the triangle. I need velocity, average, good, it has it. I have time, good, the equation has it. And I have a displacement information, good. So 1, 2, 3, and then this one is unknown. This is a very, very important point. very, very important point. If you want to solve something, you want one equation and one unknown. If that's not possible, then you're dealing with something that is much more advanced math. That would be something that an advanced honors physics class would tackle, or an advanced placement physics class would tackle. Okay, so my equation would be, I want velocity average, so I cover it up. Velocity average is equal to delta x over delta t, displacement over time. V average equals delta x over delta t. And is my equation going to answer the question? Yes, it is going to answer the question. So I've done steps 1 and steps 2. Next, I'm going to want to plug in my measurements with units, cancel and simplify units, and plug it into my calculator. Let's see how that goes. I do want to say that this is equal to the numbers I plug in. What do I put on the top? Displacement, I put that on top. 10.1 kilometers divided by the time, 0.530 hours. Those are not normal speed units, either on your car or in physics class, but that's what we have now. Do I cancel any out? Nope, it looks like it's going to be kilometers per hour, or kilometers over hours. Hey, give me a break. I'm using my phone today. It's always a good idea to use the calculator you're going to use on a test, because you might have troubles changing to a class calculator when you have to. 10.1 kilometers divided by 0.530 hours. Okay, I put the 0 in there just to be precise. We all know that the calculator uses its own logic, and it's going to lie to me. Are you ready? It says that the answer is, wow, very, very, very precise and certain. But do you think that we really know the speed of the school bus at any point with this much detail? I don't think so. But I'll write down kind of a ridiculous amount here. 19.0566038. And then what else do I need to write down? Units, kilometers per hour. Okay, it'd be so easy to say you're done because you kind of have an answer, but your answer is a lie. There's no way that anybody knows the velocity of the school bus with this much precision. I say precision because precision is the amount of detail in the measurement or calculation you have. So let's go to the final steps of our problem solving. Okay, check our answer. And finally, round to proper significant digits. By check our answer, let's think about whether this makes sense. 19, almost 20 kilometers per hour. That's pretty slow. If you were warmed up and you were pretty athletic, you could run this fast for a short amount of time. But I suppose it's possible. School buses are slow, and it's not a ridiculous number. And our units make sense. Like, if I'm talking about a velocity, it should be a distance divided by a time. Good. Kilometers per hour. Yeah, my speedometer says that, even though I never look at it. And so then lastly, I'm going to round. Well, do you know which digit you're going to keep when you round? If you don't, look at my other video about significant figures practice. Briefly, since we're doing division with two measurements, the rule says our answer is going to have the same number of significant digits as the measurement that has the fewest. Okay, this one has a decimal, so we look down at the details. We're going to go left to right, starting with the first number that's measured, the first number that's not a 0. 1, 2, 3 significant digits here, and 1, 2, 3 significant digits here. So our answer will be rounded to 1, 2, 3 significant digits. So is it closer to 19.0 or 19.1? The neighboring 5 says round up. So our final answer is 19.1 kilometers per hour. And then please box it. You can use this as a very good problem-solving pattern for answering number 6 and for any other worksheets that have similar questions, mathematical questions about physics. I'll briefly say a word about this. We already talked about the difference between displacement and distance. This is how far the school bus ended up from where it started in a straight line. Did the school bus travel in a straight line exactly? Or did it go a farther or shorter distance? Okay, thanks for watching this long video. And please check out the other videos and answer keys that I've also posted up on Teams. Thank you very much.